Okay. Hello guys, this is the homework video for homework 1, and this is about organic chemistry, introduction to hydrocarbons. Okay, so the first multiple choice asks which the following molecular formula cannot be an alkene. Okay, so alkene has a general formula of CnH2n. Okay, and A, B, and D are all satisfying this general equation, so the only choice would be C. Question 2, the skeletal diagram of 1-butene is shown as below. The Vespers geometry is presented at carbon 1. Okay, what is that? So carbon 1 will be this carbon, right? And this carbon is like a double bond. It's like a double bond with 2 hydrogens like this. So it will be a trigonoplanar. Question 3, which of the following words correctly identifies the nature of each hydrocarbon series? Let me just check my recording status. Yep, it's recording. So alkanes have only single bond, so none of the electrons are wasted. We have a saturated molecule. For alkenes, it will be an unsaturated molecule. Alkynes will also be unsaturated. So it's B. Question 4 asks which of the following molecules is unsaturated. So C10H20, this will be corresponding to a general equation for alkene. So this will be unsaturated. Okay, so continuation. So we've got the A, B, C, D for molecules. Which of the following is most likely to be correct? Okay, so A is correct because it says compound A has a higher boiling point than compound B. It is true because compound A is like a less bulkier structure, while compound B is pretty bulky. So in terms of intermolecular force, it is more effective in compound A. B is wrong because they are not functional group isomers. A and D are not even isomers. Okay, they don't have the same molecular structure, molecular formula. C is wrong because it says B has a higher melting point than D. That is not going to be true because it's bulky structure. D says the compound C is less soluble. That's not true. Compound C has a bromine functional group there. So that makes this polar. Compound A is nonpolar, so compound B should have a higher, so compound C should have a higher melting point and boiling point, and solubility as well. Okay, question 6 asks which pair of compound contains functional group isomers. There's no functional group isomer, but only molecule D is able to have functional group isomers. Okay, so the others can only form chain isomers. Okay, question 7. Which of the following rows correctly identifies that the name for it? Right, this will be C will be the right choice. Okay. Right. How many isomers does 2-methylbutane have? So you just need to sketch out every single isomers, right? So 2-methylbutane is that. So it has 2 isomers. Okay, just need to count everything up. Be careful of not omitting any one of them. And question 9, how many isomers share the molecular formula C4H8? So that's alkene. That's a butene as well. So you've got double bond on the end, and then you got double bond in the middle, and you've got this thing. And also it's saturated. It's unsaturated by 1 degree of saturation. So a ring could also be possible. Okay, so therefore total 4. It's very likely that you omitted this one. So be careful. So question 10, within propene, that's a propene, which of the following Vespers geometry represent? We've got a trigonoplanar, we also got a tetrahedral. There you go. What is the safe and appropriate way to dispose propene? It's a flammable substance. So you want to dispose in a waste container that is for organic flammables. Um, it's not an acid or a base, so cannot be neutralized. It's not acid or base, so do not rinse with acidic. Just don't put it into the organic acid container. Um, no, it's not a halogenated waste any also. So question 12, in which of the following hydrocarbons are linear and tetrahedral with per geometry? So C3H4, this thing satisfies an alkyne, which is linear here, and a tetrahedral here for this carbon. Okay. Question 13. In general, which of the following properties does not increase with increasing number of carbon in the alkene homologous series? It's flammability. So flammability is a chemical property. It does not really be affected by the molar mass, or yeah, this does not. Question 14. Alkanes are generally less reactive than alkenes. Which of the following best explains this comparison? uh, is because alkenes has this double bond, which makes it more reactive that way. And so A will be the right choice. Question 15, what is the systematic name for this compound? This is an alkyne, and then triple bond occurs at the center, so it will be hex 3-ine, right? In total of 6 carbon, 1, 2, 3, 4, 5, 6. Question 16, the formula is for a compound is shown below. So identify the longest carbon chain, 1, 2, 3, 4, 5, 6, 7, total of 7. And then there are 2 methyl groups on the third carbon and then another one on the fifth carbon. So it's 3, 3, 5, trimethyl heptane. Okay, make sure you want to minimize the total value for these numbers. So it cannot be B. And yeah, it really is quite trivial. All right, so in continuation, question 17, in which of the following pairs are the substance isomers of each other? It will be 1-pentene and cyclopentane. So a cyclic is a ring is like a one less degree of saturation, so it'll be A. Question 19, on the other hand, which of the following isomeric alkanes has lowest boiling point temperature? It will be B, because that's like a little listing. It's bulkiest structure here. That makes its intermolecular force very less effective. Question 20, which of the which within a homologous series such as an alkanes, the boiling points generally increase with molar mass. Okay. All right, in continuation, for extended response, question 21 shows a graph where the graph indicates that as carbon number increases, the boiling point increases like in this trend. So initially identify what the graph says. So the graph depicts a monotonical increase of boiling point as the number of carbon increase. This is exactly what the graph is saying, so just say it out loud. And then explain this, it's consistent. So this is consistent with the fact that the hydrocarbons of more atoms have more electrons, causing more predominant random electronic dipole, which increases the net effect of the nonpolar dispersion force between molecules. And also say that a larger intermolecular force will imply a greater amount of heat energy required to induce phase change. That is hence a higher temperature at boiling point or melting point, boiling point. Okay. So yeah, make sure to follow the steps here. Okay. Right. In continuation, question 22, we are asking for the structural formula for these two compounds, which is 1-hexene and then 2,3-dimethyl 1-butene. So the same molecular formula listing, so it's isomer. These are actually chain isomers. Okay, just make sure that when you draw the structure, carbon can only form 4 bonds. Don't make it like a 5 bonds. If you have a hydrogen here, will be wrong. Okay, draw the structures. It's asking for structural formula, so you must do the ones with the hydrogen and with all the bonds present. Okay, that's A. So yeah, you can see how the evaporation points, which is just the boiling point, is a bit different. And then question B, there are chain isomers. Question C, explain how they have different boiling points. So it's because of their geometry, right? One is bulkier, the other one is more like straight chained. So here, the compound of interest are isomers of each other. So you make sure to also mention, right? Make sure to also mention they are isomers of each other, so their molar mass is the same. We are comparing the melting point boiling points by while keeping the molar mass the same. So make sure to say it to say that we are controlling a variable. So the difference in melting point boiling points is purely due to their geometry, not because of their difference in molar mass. That's why we have isomers. So just make sure to also note that. So they have identical molar mass, meaning that their strength of dispersion force is identical, right? So the difference of boiling point is therefore due to bulkier shape of. I didn't want to write this long name, so I just draw it. Okay, you could also do that. As molecules are arranged further apart from each other, and hence the effective dispersion force is reduced in comparison to one hexene, allowing for a more compact arrangement. Yep, so that will be draw a diagram also helps, but it's not necessary. Right, continue. Question 23 wants us to compare the following two compounds in terms of their structure and shape. So compound A is a pentane, 1, 2, 3, 4, 5, and then compound B is a pent-1-ene with like a double bond. So there's two dot points, right? Compound A, the molecule is pentane, so C5H12. It consists of only carbon-carbon single bond. So the geometry around all carbons are just tetrahedral. Okay. While compound B has like a double bond here, so the molecule is like pent-1-ene. It consists of one carbon-carbon double bond, and the rest of it is just the same as before. So the molecule geometry consists of tetrahedral for the rest of these carbons, and then a trigonoplanar for this carbon. Okay. Yeah, you just need to describe all the carbons. Right. Let's have a look at question B. The molar mass of compound A is 58.12 grams per mole, and the molar mass for compound B is this much grams per mole. So they have similar molar mass, despite their different. The similar molar mass, the boiling points are different. Explain why. This question is very similar compared to question C in question 22. So similar molar mass means no significant difference in dispersion force in terms of their strength. The difference in boiling point is addressed with their molecular geometry compared to B has compound B, sorry, OUND, no OND. Compound B has a carbon-carbon double bond, making the geometry slightly bulkier than compound A, which is a straight chain alkane. Okay. If that makes sense, let's continue with question 24. So alkynes are hydrocarbons which contain a triple carbon-carbon bond. Okay, and then we are asked to draw the structure for two of them, hex 1-ine and hex 3-ine. So that's hex 1-ine, that's hex 3-ine. Okay. Question B says to describe their molecular arrangements in terms of each molecule. Compound A is arranged like this, right? So compound B is arranged like this. So their shape also looks like this, right? Because we have triple bond and then we have a linear arrangements there. Okay, and then question C says hex 3-ine has a melting point of this much, and hex 1-ine has a melting point of this much. Explain why they're different. Obviously, it's because of these structures, right? This is less bulkier than this, right? That's less bulkier. So they are position isomers. Therefore, the molar mass is identical. The intrinsic strength of dispersion force is the same, right? So geometry is the main cause of this difference in physical property. A is relatively more bulkier considering the location of triple bond, which made it asymmetrical. Also, dispersion force is less effective for compound A. Okay, explaining how they have like different melting point, boiling points. Okay. Challenging question asks you about the degree of saturation. You need to know that every ring decreases the degree of saturation by 1, and every double bond decreases it by 1 again. So we have 1, 2, 3, 4 double bonds, and then we have a ring, so a total of 5 degrees of saturation reduced. Okay? Yeah, it's a relative short homework, very easy homework. Okay? So good luck. I'll see you next time.